Hi, my name is Agnes, and I'm going to be talking about some structures that we can find in the larynx. First of all, we have the tidal cartilage that is situated above the cricocartilage, and it is connected to it by the cricothyroid membrane. Then we have the cricocartilage that is located below the tidal cartilage, and it is a complete ring of cartilage, unlike the tidal one, which is open at the back. We also have the trachea and the trachea rings. They are C-shaped rings that provide structural support to the trachea, preventing it from collapsing while maintaining flexibility. Then we have the arytenoid cartilage. They are located on the posterior superior aspect of the cricoid cartilage, and they play a really important role in vocal cord movement and sound production. Finally, we can have the cuneiform cartilage. They provide support to the laryngeal structure and help maintain the opening of the larynx.
My name is Rashna, and I'll be talking about the epiglottis, the hyoid cartilage, the thyroarytenoid muscles, the transverse arytenoid muscles, and the oblique arytenoid muscles. The epiglottis is the flap that covers the trachea during swallowing so that food does not enter the lungs. It's also consisted of a leaf shape. It's elastic cartilage attached to the thyroid cartilage and hyoid bone. The hyoid bone allows the larynx suspended from it and displays a sheet of a membrane. The thyrovocalis and the thyromuscularis are part of the thyroarytenoid muscles. They allow the vocal folds tension for sound production. The transverse arytenoid is an unpaired intrinsic muscle of the larynx. This allows the transverse arytenoid is an inductor of the vocal fold, which allows an important role in phonation. The oblique arytenoid muscle lies superficial to the transverse arytenoid muscles. The oblique arytenoid adducts the vocal cords, and the airy epiglottic parts brings the epiglottis towards the arytenoid cartilages.
My name is Lauren Casso, and I'll be talking about the cricothyroid muscle, posterior cricothyroid, vocal ligament, hyothyroid membrane, cricotracheal membrane, and ventricular folds that we also included. Cricothyroid muscle consists of two muscle bundles, pars recta and pars oblique. Both bundles originate on the sides of the cricoid arch and attached to the inferior surface of the thyroid cartilage. Contraction tilts the thyroid cartilage downward toward the cricoid cartilage, upward towards the thyroid cartilage. Because the vocal folds are attached anteriorly and posteriorly to these cartilages, they are stretched and tensed. This causes an increase in their rate of vibration, which is perceived as a higher pitch. The posterior cricothyroid originates on the quadrate lamina of the cricoid cartilage. Fibers course upward and attach to the muscular process of each arytenoid cartilage. Contraction rotates the vocal processes of the arytenoid cartilages laterally and upwards, abducting the folds and opening the glottis. Vocal ligament is formed by the intermediate and deep layers of the lamina propria. This layer is less compliant than the cover, which comprises the epithelium and superficial layer of the lamina propria, and the most compliant layer. Hyothyroid membrane, also known as the thyroid membrane, runs from the oblique line of the thyroid lamina to the major horn of the hyoid. The thyroid membrane attaches the upper border of the thyroid cartilage to the hyoid. Cricotracheal membrane consists of the cricoid cartilage with the first of the trachea. It prevents these cartilages from moving too far apart. Now, the additional The additional one that we added to the model was the ventricular folds, also known as the false vocal folds, are located inferior to the epiglottic folds and superior to the true folds, but do not extend as far to the midline. They run roughly parallel to the true folds. The false vocal folds are composed primarily of connective and some muscle tissue and contain numerous mucus glands and globular cells that help to lubricate the true vocal folds beneath them.